welcome to part 3 of this Selmer 100 PA restoration, and which we're going to mod into a guitar amp. So we're going to have this board out, remember I said, and we need to look underneath and see what's going on under there, make sure it's all safe. But what I've decided to do first is I want to get all my components in that I need to get in there, and then I'm going to lift the board up. That way I'll make sure that I'm not, because this board is not ever so high off the chassis, so make sure that there's no soda drips of drop through the eyelet and it's touching on the chassis and things. So I'm going to put all the components in and get the board right, clean, and then I'm going to lift it up and just see what it's like underneath, make sure there's no problem. We're going to be changing all these plate resistors, and I've tested some of these and they're seriously out of spec. One of them was 300k and they're supposed to be 220, so that's a long way out. So while I'm at it, I'm going to lift all these mustard caps and just check that they're not leaky. They're not often leaky, these, and they are really good caps normally, so I'm going to leave those in. They tested these two plate resistors, and they are very accurate, so I'm leaving those in as well. There's not any point in changing them unless when I run it up for any reason they're crackling, they're causing any frying or crackling. I'm leaving them. But got 220k resistors there on the grids going into the output tubes. They're out of spec as well, so they all have to be changed. And we're going to modify this bias as well, sort this bias out, get that sorted. However, there is something on here which I spotted, and whilst I've traced out a lot of this in my head, and there is certain bits that I haven't really got round to. Most obviously the channels and what I'm going to do, that's pretty easy, but this here, these two resistors in parallel, which are coming onto that ground point there, which is on the bias, but I'm more inclined to think they've just used that ground point and it's nothing to do with the bias. And then they come down to a resistor and then another resistor, and then that goes off and is connected into this impedance selector switch there that's on there. So I'm not sure yet. I'm going to have to have a look at that and trace it out. It's also going up off a resistor there, and onto that pin of that valve, so I need to just check on that F86, and I need to check what, sorry, I'm looking, pointing at that onto there, so I need to check what that is as well on there and find, and I don't know what that is. So is it some kind of negative feedback? These Hunt's capacitors on here, these will be leaky as well, so guarantee they'll be leaky. I've never tested one of them that isn't. So I'm going to get on now and make a start of this board, and then we'll have a look at it when I've got most of the components done, and then we'll have a look underneath. So yeah, I just tested those and they did measure it shade over 600 ohms, which will be about right. So they're again quite accurate, those. So, but you can't get a reading across them when they're in circuit. I'm going to leave them up because these resistors need to be changed. They're way out of tolerance, and this all goes into the bias and things, so I want to change all that, so I'm just going to leave them up for the time being. So I tested the rest of the resistors, and they are actually slightly out of tolerance. That's, I think it's about 2.7, something like that, instead of 2.2. That's 11k instead of 15k, and that's about 119 ohms. So there is some discrepancies there in the tolerances on those, so a bit of an head scratcher, I think, about that. So I've lifted this coupling capacitor up here, and that'll allow me to test it now. I've remove one leg, so I've took out the 220k resistors. One of them were just laid across top, but never mind. So what I like to do with these is suck all the soda out the eyelets, get rid of all the old flux there, clean around with the alcohol, clean the board as I go along, and then resolder it all up so it looks as good as new. So we're testing the first of these 15 nanofarad mustard caps that we've got. I'm betting you that these don't leak. So got the meter, we're all hooked up. Let's press that. Told you, 15.41 nanofarad and no loss. That is perfect. Right, I've had a bit of a brainwave here. So obviously I'm going to mod these two channels so they're different. So while I'm here, I'm going to start doing a few mods now. I've decided I'm going to take advantage of the fact that when I strip these two channels down, the two channels we don't want, obviously I got more mustard coupling caps. So what I'm going to do in this channel 2, I'm going to put another one of these coupling caps into these eyelets that I cleaned out, and that was the previous channel that I've cleaned out there, and I'm going to bridge from there to there and there to there, and I'm going to wire that coupling cap. I'm going to wire those two coupling caps in parallel. That will give me 30 nanofarad as opposed to 15 on the other channel. So that will give me a bit more bass response, a bit bassier channel than the other one, and that's what I'm aiming to do, is make the other one a bit more bassier, a bit more bassman, where the other one is going to be more towards that Marshall type sound, more for lead guitar, you know, and this one more for this second channel, more for clean tones. Whether it'll work or not is another thing, because as you know, I do everything by trial and error. But that's what we're going to do. So we're going to take advantage that we've got those, because I've just tested one of them that I took out, and again, there's no loss on them. Every one of these capacitors, you can bet, will be spot on. They're absolutely brilliant caps, because there's no reason to take them out, so I'm going to use them. There we go, they're all soldered in. Quick blast over with the alcohol just to clean off any flux. And there you can see I've paralleled those two 15 nanofarad capacitors together. We should have 30 nanofarad there, or thereabouts. So the other coupling capacitor for the other stage, because that's the plate resistor for this side, this stage, and now this is the second stage. That's the coupling cap. You can see there it's connected there with that piece of wire, and it's going to there, and then it's going on to, that's going on out to the tone stack through that grommet there. So it's going to be a bit more difficult tagging on one of these other 15 nanofarads, because the leads aren't very long on them, because obviously they've been used in this board, and these are a bit fat and bulky so the leads, we might have to extend the leads if we want to. I don't want to do that, it always looks a bit botched on it when you've extended leads, but it's the only way we're going to get that to go over it, I think. So I'm going to have a look at that next. Just tested that next coupling cap. Look at that. That's nearly 50 years old, that cap. No loss. And it's 15.2 nanofarad. How accurate is that? That's unbelievable for a component that age. They really are good quality. Struck lucky with that one. It's got a long enough lead, so we managed to parallel that over. Pushed it up, because what we don't want is it touching that plate resistor, and the reason for that is should a fault develop on that and that plate resistor starts to heat up and burn, it's rare but it does happen, it'll take that capacitor out with it, burn it all. We don't want that, so we've lifted it up, make sure it ain't touching that. That one is touching slightly there, so but this is not, so obviously this one is not soldered in yet, because the wire's got, the feed's got to go in there, so I've not soldered that one up. So I might just when I've soldered that in, I'll just have to hold that across to get my gap there. Now these, when these come out of these coupling caps, they go into these 470k resistors, and there's two of those, one there and the other one's there. It's like a mixer, I would imagine. The 470k is quite a high value, so I'm presuming that there's quite a lot of gain coming off. Well, there isn't really a lot of gain, is there, on two triads? You wouldn't think you'd have a 470k grid stopper, even though they're mixers. So they might be a candidate for being reduced. They also, so in Marshall's JCM 800s and things, I've seen those 470ks because there's a lot of gain. And what they also do is put a bright cap over them, because of course that amount of resistance is obviously stifling some of the top end. So I've seen that done as well. But I might change those, and in fact I seem to think that on the I don't know if it's the Basement or one of the Fender amps, they've got a couple of mixer resistors to blend both the channels into the one of the stages, and I seem to think they're about 220 or 270k. So that might be a value to go with there. So we're going to have a look at a schematic and see what's going on with that as well. Now I'm moving on to the next channel. Again, we want to make this different. What I want to do is have a look at the schematic again and look at some voltages. So looking at the preamp part of this schematic here, incidentally on this you can't see the actual drop in resistors from the power supply. You can see the 10k, which is, where is it, there's the 10k, and you can see that goes straight on and straight into the phase inverter there, phase splitter. That's 300 volts there we've got on there. And then we've got a 270k resistor there, dropping down to that EF86. But obviously there's an assumption of where these two crosses is where they actually connect in. There's no drop-in resistors in this, but we know it's 220k because we know that's what are on the amp. So another discrepancy there again, 270k, we've got 220k. Now if we zoom across here, we've got 110 volts on the plate of each of those. That's with a 220k plate resistor. Now we're going to have the assumption here is it's 270k, so 220 we're going to have a little more than that, we'd think. Let's have a look at a Fender schematic. This is a Basement 100, and if we hone in on here, we can see we've got a voltage of, I don't know how close, yeah, we've got a voltage of 240 there with a 100k plate resistor. So remember, this amp is a PA that we're working on, and so we assume that there's not going to be a lot of gain on the channels, because the last thing you want if you've got a microphone through it is it to be clipping and distorting. So we can bet that these channels are very clean. So we want to make at least one of them a bit more throaty. We can start by increasing that voltage. The main thing, one of the main things I want to change is that 220k grid leak resistor there to 1 meg. So that's another change I want to do. Now we've got 2.2k and a 25 microfarad cathode bypass cap. So cathode resistors 2.2k. It's 1.5 on the Fender there with the 25 microfarad. On a Marshall I think it might be 2.7 or even, I can't remember. So that's something else to look at. So we'd like to get this voltage up a bit on this valve if we can, because we want it on the second channel, want to beef it up. So I've left basically I've left those, the channel 2, I've left the two, I put the 220k's in and just replace those, and we're going to have somewhere around about 120-30 volts I would have thought, because obviously remember we're using a 220k resistor and not a 470k, which is on this schematic, so I presume we're going to have a bit more voltage. Oh, I could be wrong. There's the 470k resistor there, and you can see that's where they mix in. Remember, this is times 4. They're only showing you one diagram of that actual channel. Now, I don't know on the basement because I'm not really familiar. It's just what when I've watched videos on YouTube and things, and I've read a few schematics. But I think we're looking at something like 270k instead of those 470s, or maybe even 220. But if we say 270, so I think we could change those, and that's going to also going to give us a bit more, probably a bit more gain again there. So basically what we're trying to do is nab little bits of gain from various component changes, and all that'll add up into a big change. Remember, this amp's got a master volume on it, and much as I don't care for master volume, that gives us a chance to get this channel overdriven a little bit, and get the volume down. And considering it's 100 watts, that's probably not a bad idea. I certainly won't be cranking this up flat out to get the sound that I want, because one, I've got nowhere to do it, and even if I used it for a gig, I'd probably only have it on number 1, and that's why I don't use big amps when I'm playing live, because they're just I use small amps because I can crank them and get the sound I want. Right, so I've actually got all these in. I have to clean this board up. Notice a bit of a crack in it. You perhaps can't see it on camera, but there's a bit of a crack there, but it's not a detriment, I don't think. So 220k instead of 470k, 220k instead of 470k, that's the mixers. Channel 2, 30 nanofarad, 30 nanofarad in and out on both triads. Normal 220k plate resistors, wires got to go in there, that's why that's not soldered up. Now then, 100k plate resistors, 1 watt. So I've put them in, so when I run it up, I'm just going to do a quick calculation and make sure that the current draw is below 1 watt. It should be. I can't see that being much over, but it's just with this different, like I say, the way these drop-in resistors are laid out different. So that whole section of the board's done. I've shortened this wire a bit just so it's so there's less slack on it. So now we're going to move over and start looking at this section. Leaving those, we need to lift. These are the main coupling caps that go into the output tubes, and do we know what value they are? They are 0.1s, so 100 nanofarad in effect. So we'll test those, just make sure they're okay. Those 220s have got to be changed. They're absolute mile out. They're the resistors going into the grids. They're the grid leaks, aren't they? Grid leaks. And there's the bias connecting to those. So these resistors are out of tolerance, and I think they're only in that what I think is a negative feedback, but I'm probably going to change those anyway because they are out. Might just put it back to how it were. Might experiment with putting a switch on that negative feedback. Might not. Switch it out and see what it does. And then there's this mess here that we've got here. You can see we're opening in. This is where feeds for the EF86 and the old dirt rhinestone cowboy's been in there, so we need to just tidy that up a bit. These that resistor there's 470k. I think when I measured that it's about 600k, 600 and something k, so that's well out of spec. And then that 100k there we're going to change, and we've got a, what's that, 3.3k going onto that phase splitter. So not sure was that right, going on there. Pins 2, so that's a grid stopper, is it? Pin 2, that's a grid anyway, so I presume that must be it. That'll be a bit low for a grid stopper. I'll have a look at that. We'll look at that in a bit more detail. And then we've got this rather sluggish looking thing. I don't know what that is, can't really see, so we're going to have to have a look. Sorry, I'll just let that go off camera. Look, go again. So that component there we need to have a look at, whatever that is. We need to look at that and get rid of him, get him changed, and then that'll be pretty much, then we can move on to the bias. That tested okay, so we don't need to do anything with that. Then we just need to look at this bias. When that's done, I'm going to lift this board. Got one or two burnt wires here, just like that. Let's just move that there. That's been caught with a soldering iron by the looks of it a couple of times, so I think I'm going to change those. I don't like to see that. I mean, it's not actually gone right through, but so what's that feeling? Everybody thinks, you know, last person that came in here must have done that. So I think I have done it, so I ain't leaving that. These could be screen cable as well, because they just fixed. These are the grid stoppers going into the grid, so might look at changing those for some screen cable. Right, so I've done some more work here. Replace these resistors, which were massively out of tolerance. This capacitor here, which is this, is what I took out. Sorry, we'll just move that back so it'll focus. So what we took out is 100 picofarad, and it tested. It didn't test leaky. It's pretty accurate, but it's a bit greasy, and so I decided it's a bit grubby. So I've removed it, and I put 100 picofarad. That's 3 kV, so that ain't gonna. That's all I had. So I put that in. So that'll last. That should last a while. Now this 100 kV, I'm not quite 100 picofarad capacitor is also connected to this 3.3k resistor, and then that goes on to the screen of the pin 2 of the the control grid of the ECC83 for the phase splitter, one half of the phase splitter. That's also DC coupled from that 100k resistor there. So there's a join across there. I've not put that in, obviously, because the board's coming out. So that's why all those cables are at. Not sure what that's doing. I would whether it's to get rid of some oscillation or what, I don't know. Don't really know whether it's something to balance up the foot. I really don't know. So again, anybody knows what that is, then put it in the comments. I'd be grateful to be 100% what that's doing. Not quite sure. Not seen anything like that before. So that 100, it's across those two resistors there. The 100k, which is feeding the anode or plate on the EF86, and then that's going into, so whether it's something to do with it being DC coupled, don't really know, but end of the day we've put that together as it is on the schematic. So that's all that. Now that's all them resistors changed, and we've done some slight mods there, where on this one we've made those 30 nanofarad on channel 2, and then on channel 1 we've dropped the plate resistors down to 100k, but we're keeping that 15 nanofarad. And then the rest of the mods I'll do after, which will be those grid leaks, which incidentally are fastened on the jack sockets on the front, so they need to be 1 meg from 220k. And then we've just got to look at the cathode, which is there, cathode bypass cap there, just hone in there, and the cathode resistor, just see what we're going to do with those. Well, the same on the other channel. So that, and then the next job now is to redo this bias. So this cap needs to come out. It's ancient, been in there a long time, so we've got a capacitor for that. New diode. Right, I've got the board up, and it don't look very good, so let's just hone in and have a look at the state of the terminals. So with these all being soldered from the top, finish up with these code solder joints. I don't know how close I can get before this camera says ain't focusing anymore, but you can see those. But here's another thing, look at this hanging down. If we just get, I can just get around, sorry. So look at this hanging down there. So that's not a component that I've pushed through, that's an old component. So when I've pulled out that old resistor, it snapped and left that on there, and then the solder's run down it, and of course that's really close to bridging out, and you can bridging out onto the actual chassis itself. So this is why, you know, I wanted to pull this board and check what we're going on underneath. You just never know, and that's a typical example, because that, and it's just, look, just broke that off, it's just hanging on the end there, and then the solder's run down it when I've soldered it in. So I don't know whether that would be touching the board or not, but it'd be close, and it'd been much longer, it certainly would have been. But, so we're going to clean that up now. What else have we done? So we see here, so the bias pot conundrum goes, so I looked at putting it up there and it would go there, but the problem was the aluminium and the chassis are too thick for the thread on the pot, and if we look at the pot you can see it's only got a small shaft on it. So then I had the ingenious brainwave, because this board doesn't flex at all, and certainly where that is, because the problem with flexing it is pushing it down, and it, you know, it, although it probably would be all right if it did touch the chassis, but we don't want it to. Now I've put these two radials in. I can hear one or two people going, "Oh, radials on," but I've put these two radials in. One of the reasons is the only values that I had. Decided to use a slightly different bias set out than I was going to do, and I've copied this off the 5E3, I think, can't remember, but I can't remember. I've copied it off it's off Rob Robinette's website, so if it's good enough for him, it's good enough for me. So I've put it on here, and I may have to tweak with the values. So I've drilled it through there, and by the time I've got a lock nut on it, which it doesn't have incidentally, so I've got to root round and find one of those, a lock washer, so I'm not putting it on with that one. We don't want it coming loose. So by the time it's got that, there's not going to be very much showing. And if we look up, just that's hooked onto those things again. So if we look up, there's not, you can see there's very little there protruding out of there. So I think we'll be fine, and there'll be even less. And when you look down at these are obviously not touching the board, and they are thicker than that, or certainly as thick, so that's going to be absolutely fine there. And I've only been able to put that there because of course there was that big red capacitor going across there, and I've managed to clear that space, so that's worked out really well. Kept it all grouped and together as well, rather than draping wires all the way up to here. I can now just there's, and I've got that, just wire on there, and job's a kipper. You can also see on this board we've got some carbon going along here, all the way along there. Perhaps can't see that, but it's going all the way along there. So I don't know whether there's been a bit of an explosion at some point, but I'm going to clean all that off before I put the board down. Actually, I've just realised I'm going to leave the board up because it makes it easy for me to work on these tubes, these output valves, which I'm going to be doing next. These tube sockets for the L34s, got the screen resistors to put on and whatnot, and the grid stoppers. Right, we've moved on a bit, so I thought I'd move this project on because these videos are getting a bit long. So what have we done? So I've wired up, you can see here, I've wired up all the power nodes now to the preamp tubes that we've got, so those are done. I've done the, you can just see in there, you can just see, I'll have to turn it around for you to see them properly, but for the time being. So I've got all the output tubes done, the screen resistors are on and everything, and you just see those there. I've also had to rewire the filament, the heaters. They were wired up with hookup wire, and the plastic outer covering core of the wire was just cracking when you bent it, and they were flimsy. So I've removed those, done those, redone those. The other thing is that all the tube bases were loose. There's no locking washers on there, no spring washers. So I've had to order some of those, because obviously they're Imperial. I've only got 3mm, I think they're 3.5. So I've had to order some of those. So there's and of course the grinds for the cathodes are fastened on with those nuts. So you've got like, see if I can show you on the, might be able to just see it, but there we've got I can't see with my finger it way. There's a ground lug on there, and obviously that's now the ground lug's coming loose on there, so they were really loose. So I've nipped them up for the time being, and I'm going to put these washers that I've got coming on there. So there's one. I always put spring washers on your on your tube bases. This amp's 100 watts. When it's vibrating away on the cab, they've obviously just vibrated loose over the years. If you can hear that noise, that's the door, and what that is, it's the bottom bolt on the door, and it's been rattled by someone. And if we open the door, we can see who's rattling it, can't we? So that's Pink's door knocker, the bottom bolt on the door. So the output tubes are all wired up and finished, the L34s. So I put the screen resistors on there, and we had those, remember we just had those two botched on, which were serving all the valves. So we've now got one on each valve seat, and I've moved them over to the sides so they're not over the tube bases getting fried. I have got the grid still to wire up, but that's not a big deal. We need some screen cable for that, I think. It is turned off, and it's just as well, because someone's popped up to see us. There she is. She's in one of her moods at the minute. It's Pink, but anyway, as long as we ain't got the electric on, we'll be fine. So that was the one thing. Now, I don't know if you remember that there were two resistors in parallel here, two really big ones, which I said I didn't know what they were, and then suddenly it dawned on me that was actually a dummy load that was in here. And one of the reasons why I twigged it was when I was running it up, it was getting really hot despite the speaker we plugged in it. And then obviously this is the lead that goes to the impedance selector, and it will go into ground. And then suddenly I thought, oh yeah, it's a dummy load, but I've took it out. I don't think we really need that in there, so I've removed it anyway. So that solved that conundrum. What else? So yeah, so overvolts on this, I don't know whether we covered that in the last, overvolts on this EF86 plate, and the imbalance between the plate and the screen on that EF86. The imbalance is still there. There's 10 volts more on the screen than the plate. There really shouldn't be with pentodes. What are you doing in that corner, Pink? I think she's trying to thieve my snacks. She was trying to thieve something. If it's food, that's Pink. So that, but what I have done is, and I'm waiting for some 27k resistors, as I think I showed this before. I've got 30k in there in series. That's just tacked in for the time being while we were testing. And I've got that voltage is on that plate is below 90 volts now. And excuse me, Pink, that looks like something of my lunch. Thank you, I'll take that if you don't mind. No, you're not having it. Dear, oh dear, this cat's a thief. So where was I before I was rudely interrupted? So yeah, so I think when I put that 27k resistor, 270k resistor, there's 300k there, I think that'll balance that back up to 90 volts, which is what should be on the schematic. So we should be about there. I think we've got 79 volts on it now, but we were way over with a 220. We're quite a bit over there. And again, another variation on the schematic, 270 on the schematic, 220 in the amp. I find loads of different, loads of things that are different in this amp than is on the schematic. Now the other thing is this DC coupled phase inverter, phase splitter. So that should have a voltage of 300 volts on the plates of this phase inverter, and we have got about 320 volts. On the schematic, 180k, 150k in here. I think that's my snacks gone. I think they're being opened and eaten. Never mind. I can't have nothing in here. So yeah, so those 180k, so I've ordered some 180k resistors, and I really can't see as we need them as big as that either. I have a feeling someone's put those in, although they did look like factory. I've just got a feeling they're not original. And they were the same type of resistors as the dummy load, so they may be. So that should balance that out and leave us about 300 volts. So that schematic is actually quite accurate. It's just that things in here don't coincide with it.